Hi, welcome to this third day of the Programmers Week 2021. And I hope that you have been enjoying all the great content that we've been offering along the week. My name is Felipe Ortiz, and I'm a software engineer and community lead for the .NET Guild here at Cognizant Softvision. Today, our main focus is to take you on this journey called .NET Core meets gRPC meets JavaScript, synergy at your service, and discover the great advantages that you will gain by having a gRPC backend, how you can communicate between your backend and your web application through gRPC, and how it accelerates and empowers your development process, and also how it compares to a more standard approach via a REST API. So first thing first, just in case that you have missed our earlier tech talk about gRPC, let us do a brief recap and review on gRPC. gRPC is a fairly recent, 5 years or so, open source remote procedure call system designed by Google in 2015. It's the evolution of their private RPC infrastructure called Stabi, and it uses HTTP2 for its transport, protocol buffers as its interface description language. This makes it language agnostic and provides us with features such as authentication, bidirectional streaming, cancellation, timeouts, etc. To establish a successful communication between your client and a server, we need a protocol buffer to define a common ground for our applications to interact so they can have a better smooth interaction without the hassle that we used to have in a REST-oriented API. That means having a common message model between our applications, serializing and deserializing the message sent in JSON format, and only then moving forward with our process. By using protocol buffers, we guarantee that our requests and responses will stay the same across the applications that needs to use our services. In this approach called Proto First, we define the common ground and model the messages that are going to look like in our application and what kind of requests are we going to handle and what kind of replies our caller should expect. Once we model it, we use the corresponding gRPC tools to generate such language-specific code and do our own work. The code, the tools output, and the protobufs being strongly typed contracts make your applications resilient. And the need for handcrafting JSON object calls is eliminated, as well as having to hunt down any API documentation afterwards. Your protocol buffers now become your way of documentation. Now, let us see a basic example of what a protocol buffer looks like. In this example, we have three code pieces: our service definition and the structure of our request and response messages. And here we have a service called greeter that only has one RPC defined, say hello, that accepts a hello request and responds with a hello reply message. All that it is contained between the brackets of our messages are going to be the properties that we need to use in our methods, such as an ID to fetch a record from our database, or some model that represents the user that just has registered in our e-commerce platform. Therefore, by having such a structure that defines the message that is going to be sent, what kind of message we should expect, we eliminate all kind of uncertainties that sometimes arise with REST API implementations. And also remove any dependencies that we may need to document our endpoints, such as Swagger. Our contracts just became explicit. Next up on our agenda, we have Svelte. Svelte is the new kid on the block of JavaScript frameworks. As you see from this result from the 2021 Stack Overflow survey, it came up as the most loved JavaScript framework with 71% acceptance rate. It has more than 50,000 GitHub stores, and it's used by some of the big names of the industry, such as Square, Apple, IKEA, the New York Times, etc. Created by Rick Harris, a graphics editor from the New York Times, it was designed with reactive programming in mind. But what is reactive programming? According to Heinrich Apfelmus, it is the essence of specifying the dynamic behavior of any given value at the time of declaration. Harris saw and also drew some of his inspiration from his wife, seeing her working with a lot of spreadsheets, but don't quote me on that. He saw that it's all about data flow and tracking values through our application. If something changes, our application should react. And as you see here, we have a fairly reduced example of what is happening behind the scenes with a React and a Svelte application. In the React world, each of the components that we have defined in our application gets evaluated and parsed, set up into a tree structure into the virtual DOM, and finally rendered in our web browser. So how can React update our application whenever it changes? Well, to reflect those changes in our browser, React leverages the values stored in the virtual DOM and checks every one of its nodes and tries to determine if any of those values have changed. Svelte World, on the other hand, doesn't use any virtual or shadow DOM as any of other popular libraries or frameworks. It uses a compiler to ship a pure vanilla JavaScript file, and Svelte interacts with the plain old regular DOM to update its values on the browser. So let's see how React and Svelte manage to achieve reactivity in a simple example. On this side, we have a quick to-do list. Each item on this list has an event listener. And if we click on any item, it will append a thumbs up emoji. And internally, we will mark it as on. This whole function executes from top to bottom for each change on any of the listed items. So we use a useMem hook to optimize our code a bit further and only recalculate our filtered items if the check on the hide item checkbox is selected. Now, on the other side of the code, we have the Svelte implementation. At first glance, we see that it is much leaner and concise, but there is one keyword that is not often seen in JavaScript. That is the $sign, or more technically, is called a label statement. And what it does is it runs your code on topological order. This is just a fancy way to say, in this example, filtered depends on the value stored in hide DOM. And if it changes, we only need to recalculate its value by filtering the to-dos that haven't been completed. pretty much like a spreadsheet. We just update the pieces that we need rather than running our whole function as we do on React. These make our applications more fluid and truly reactive. For this and many more reasons, we chose Svelte for our proof of concept. We wanted to have a lean application that could leverage a Swift RPC backend and rapidly change its values on the browser and also have room for growth. The downsides at this moment are that the official ways to build applications with this framework are still on beta. Although the theme behind it's very active and supportive. Also, it doesn't have the most mature development tools that the other libraries or frameworks has. And also the community support is small, but tightly knit. Now, having covered all the introductions of these technologies, how can we manage to build an scalable, highly responsive web application using the power of gRPC? And how does it compare with more standard approach of having a RESTful API? Well, since browsers doesn't support HTTP2, at least not on the full extent of what is expected for gRPC, we need to come up with a solution much as we see on this diagram. We need to proxy all of our RPC calls via Envoy to gain access to our RPC methods. But nowadays, and thanks to Microsoft, we have gRPC Web for .NET. This allows us to handle all the requests that have been made through our web browser via HTTP 1.1 and be able to interact between our web application and our web gRPC backend. To achieve this, we need to configure our server application to handle gRPC web. We can accomplish that by adding a NuGet reference to grpc.aspnetcore.web, as you see here. And then in the startup file, we need to configure our application to support gRPC web. With the use gRPC middleware. Next, we need to map the gRPC services that we are exposing. We need to enable support for gRPC. And also, if you need to use CORS policies, you can also provide such configuration at this step. And now, in order to connect our application with our backend, we need a tool called Protag. You can fetch it from the official gRPC GitHub repo, and also the gRPC web plugin from the same repo. When you have it installed on your machine, you need to run this command and provide your relative path to your Protos folder, living in your web application, and an output and directory for the files generated by this tool. Be mindful that for the import style that you select on this step, you have support for Clojure or CommonJS styles. If you want to use TypeScript on your application, there are a couple of community projects that are trying to achieve this. But most of them are at alpha stages. For the wire format, you have two methods to send your payloads to your server via gRPC web text and gRPC web. The first one is base64 encoded and has support for unary and server streaming calls. With gRPC, however, the payloads are sent in binary binary protobuf format, and it only has support for unary calls at this moment. When the tool has finished, it will drop 2 files on the specified location. One that contains the gRPC web client that will interact with your backend, and the other one contains your protobuf definitions in your JavaScript. Okay, so let's go to the demo itself that I have prepared for today. So in this example, we have here our gRPC server that only has one service exposed at this point in time, that is this meeting service. And I have my protobuf buffer that defines my servers, that is called meetings. And I have exposed a couple of messages to interact with in this service, and that is get all meetings that will return a list of meetings, a meeting lookup model that will provide me with just one instance of a meeting, and a couple of methods to delete, to toggle favorite, and also to create a new instance of a new meeting. And here, if you see the implementation is just one context that is necessary to perform the operations with entity framework. And it has all the methods that I have defined on my protobuffers file. How to get all the meetings, how to get just a single instance of a meeting, how to create a new meeting, also how to edit one, and how to toggle the favorite meeting on such an instance of a meeting, and also how to delete it. And yeah, that's basically what I have exposed. This models folder is just the plain old context and one definition from what I have stored on my database. It contains all these properties. And yeah, it just exposes that. And in the startup, I have allowed cores in order to work in my local machine. And yeah, I'm just mapping that endpoint and enabling the gRPC, and also allowing all cores calls between my two applications here on my local environment. And for the web application itself, this is much what you will encounter on any given Svelte application. It's composed of a main file that will target the document body on your HTML. And on top of that, it will call whatever you have defined here on your app.svelte file. So let's see it in action. So this is a project that is called Meet Us. It's just a bunch of all the events that we have here at this Programmers Week, and it just lists all the items, and it put it on a card, and you can toggle your favorite status for any given talk that you would like to see, and also it can show you the details. And if you see, we are making all of the calls via gRPC. And if you see here, also, it's blazingly fast. It just it doesn't compare on what we have on REST-oriented API. It at least the median time that we have shown on this example is on the order of 50 milliseconds, and give or take. And yeah, you can interact with all the application, and in to achieve that, you have these two files. One is your protobuf definition, and it will interact with your backend, and also the client has all the methods that you have defined on your protobufs. Though, and these two files are going to be generated by using that product application that I stated before. And what it looks like, it's more like this. You will have your requests here that you're going to call in your gRPC backend, and you will need to construct such a service that interacts with your backend. And also, when all the interaction and all the files are created, it exposes two methods. One, you can have it with async await and go with this whole flow. And also, one is that is based on promises and accepts promise chaining. And this is more or less that you will get with Protoc at this point in time. And I try to come around with this gRPC methods file just to abstract more of the logic that it is required to communicate with gRPC. And for example, in the app.svelte file, we are fetching them the meetings as soon as the component gets mounted on the DOM itself. So I'm just calling the fetch all meetings function that it will communicate with my gRPC backend, and it will get me a response, and that's plainly it. It's like you're interacting with a part of your application, and you have modeled it in such a way that you know what you need to get from that part of the application, and you use it as it was on your own, and you just map it the way that you have built it on your application itself. So how about we just add a new meetup like this, and for the title, we will put testing my new gRPC web app. And for the subtitle, we're going to put Programmers Week 2021. And for the address, I'm going to provide just like this. And for the image URL, I will fetch one that I have saved prior to this. We will put test.test.com. And yeah, and for the description, we will put third day of Programmers Week 2021 .NET rules, like so. And we will save it. And yeah, We have it right here. And if we show the details, we have just saved this information. And if we see our backend, you can see that I have saved all the necessary information. And this proves more or less how you can connect those two applications and using gRPC web as a way of communicating with your application. Okay, and yeah, that pretty much makes it for today. I don't know if you have any more questions that you would like to ask, or
Hey, yes, there's a question.
yeah.
Great work. Thanks for the talk. Svelte seems to be really interesting. What can you say about its adoption trend? Would you recommend it for a new application, or is it not mature enough?
I will say that it is mature enough. As I said before, Square is one of the big examples that I can find. And also I'm aware of a company that in Brazil uses it as for its point of sales endeavors. And they have this application on a little device, more like a cell phone, and it's running in, I believe it was 215,000 instances. The only thing that bugs me at this point in time is, well, SvelteKit is still on beta, but nevertheless, it's proving to be such a big trend, at least on web development, because you can achieve such a lean application, and it removes all of the dependencies that you have. When you build your application, at least this proof of concept comes around in 200K, more or less. So the great power and the great advantage that Svelte offers at this point in time, first, that it is that it is compiled. Second, it's very lean. Third, if you come from, I don't know, React or Vue, the learning curve is not going to be two step in comparison, let's say, with React, that you have a very step curve in gaining more, getting a feeling on how you can develop highly performant applications. Yeah, that is all that I have to say. I don't know if I get to answer your question.
I have another question from Alan.
Yeah.
He says, great talk. Unfortunately, I couldn't be from the beginning of the talks, so you probably may have covered this question. Anyways, ProTalk is agnostic to the technology used on your applications?
Yes, it is. You can use ProTalk. Let's say you have defined all your protocol buffers in such a way that your domain needs it. And let's say you want to target, I don't know, Ruby, for example. You could do so. You could use ProTalk to generate such a code, such language-specific code to target, I don't know, Ruby or Java or Objective-C or maybe C# and in this example. It's not bounded to, well, not bounded in, at least it has some supported languages, but the target of using protocol buffers is to abstract the boundaries that you have on your language. It's just defining how we can interact and communicate each other in our applications. The language specifics come in another step.
Great. I don't see any other questions. So
okay.
We have a lot of great reactions, Felipe.
Okay, thank you so much. Well, that will wrap it up for today. Thank you so much for coming, and I hope that you will enjoy all the great content that we have prepared for you at this Programmers Week 2021. And thank you so much for coming, and have a great rest of the day.